Click the bell icon to get latest videos from Ekeeda.
Friends, in the previous topic, we have discussed about the Aufbau's principle, and that we have got to know that is how we can fill the electrons in different orbitals based on the energy level. And now here basically we are going to talk about the Pauli's exclusion principle. So what is this principle? What does it states? Let me talk about that in this topic. So friends, before understanding the Pauli's exclusion principle, let us understand its statement. So it states that no two electrons in an atom can have all the four quantum numbers same. This can be explained with the help of an example, and the example that is what I am going to talk about is, suppose friends, if I am considering an atom of helium, we know that is the atomic number of helium is 2. So for that we could write the electronic configuration here as 1s2. Here basically we can find that as the s subshell consists of one orbital. So this is the representation of the orbital, and it consists of the two electrons. So this are the two electrons, and the both are of opposite spin. Suppose if I'm considering the first electron. So for the first electron, we have to find out the quantum numbers. So for that we have the principal quantum number, that is n here, because this electron, it belongs to the first shell or the first orbit, so therefore the value of n is 1. So let us find out the another quantum number, that is azimuthal quantum number, which is L. But we also understand that is this electron, it belongs to the s subshell, and for the s subshell we have the azimuthal quantum number as 0. Now let's talk about the magnetic quantum number. So the magnetic quantum number for the s orbital, again it is 0, because the formula is 2l plus 1. So in that case the value of L, since it is 0, so 2l plus 1, it is nothing but it will be 1. That means it will have only a one permissible value, that is 0. And now let's talk about the last quantum number, that is spin quantum number, that is denoted by s. So basically here we can find that is the electron, the first electron, it has a positive spin, that is plus half spin quantum number value. So here basically we can find that is the principal quantum number is 1, the L is 0, M is also 0, and the S is basically plus half, because this plus half, it indicates that is it is in upward direction, as you can see, that is represented in this orbital. So now let us talk about the second electron. Suppose if we consider the second electron, then we could find that is the second electron also is belonging to the first shell, so therefore the principal quantum number is 1. Since it is belonging in s orbital, so therefore we could find the value of L is 0, because it is belonging to the s subshell. The value of M, again it will be the same, that is 0. But if we consider this second electron, the second electron is pointed downwards, which means it has a spin quantum number of minus half. So as you can see over here, that is all the principal quantum numbers are the same except the spin quantum number, which indicates that the two electrons will not have all the quantum numbers to be the same. Here we can find some difference, and these are the two difference. So this was related to this example. Suppose if I consider the another example. Suppose if I consider lithium. So lithium has an atomic number of 3, that is Z is equals to 3. And suppose if we have to find out the electronic configuration, so we could write it in the form of 1s2, 2s1. So for that we have the representation of the orbital, which could be given as, because the both are the s orbital, so here basically I am just representing it with a one box and one box over here. And we can find that is in the first shell, which consists of the s subshell, it consists of 2 electrons, so I am representing it here, the one which is in upward direction and the second one is in downward direction. And here basically in this second shell it consists of only one subshell, that is S, which also consists of only one electron. So the electron will be represented in this way. So here suppose if I am considering the first electron and the third electron, let us consider this too. So suppose if I am considering the first electron, then I could get to know that is the principal quantum number, that is n, it is been found to be 1. For the azimuthal quantum number for the first electron, we could find that is since it is belonging to the S subshell, then the value of L here it will be 0. For the magnetic quantum number, again it will be 0, and the spin quantum number it will have a value of plus half. Suppose if I consider the third electron, so in this case suppose if I am considering the third electron, so I'll get to know that is the principal quantum number, that is this third electron, it belongs to the second shell, so therefore the value of n it will be 2. Since this third electron it belongs to the S subshell, so therefore the value of L it will be 0. The value of M for this third electron it will be again 0. And since this electron is represented in the upward direction, so therefore the value of this one would be plus half only. So here basically you can find that is there are many similarities in the quantum numbers, for example L, M and S, but here we can find the difference in the principal quantum number, which indicates that 2 electrons will not have all the quantum numbers to be the same, and that is nothing but the Pauli's exclusion principle, and this was nothing but an example. So that's it. So thank you friends for watching this video. I hope you have understood this video very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe eCreate channel. Thank you so much.